Okay, so the breadth first search is a different way of finding that spanning tree, and it's also going to be used for other things, but let's just discuss how we're going to find that spanning tree. So depth first search essentially we just activated one node next and we continued on until there was blockade. So it's very like you're solving a maze situation. Whereas the breadth first search, what it's going to do is instead of going all the way down the path and waiting for blockade, what it's going to do is it's going to search every single branch connected to that activated node. And it's going to activate all the nodes that are adjacent to the previous activated node. And it's going to go through like that. So in other words, it's going to look or search through the breadth of the graph instead of the depth of the graph where you just keep going down and you have more of a longer path situation happening. Here you're going to find things that are called shortest paths, which we're eventually going to get to. So the idea behind this is you select any vertex and you activate it. And again, in this course, we're going to give you which vertex to select. But in real life, you will have very specific outcomes that you want, and you would utilize those outcomes to decide which one you want to activate. So we have our route now. Then we're going to activate all the adjacent vertices. So different to the depth first search, remember depth first search, you only activated one vertex. In this one, you activate all the inactive adjacent vertices. So here, you look for any vertices adjacent to the activated vertex, and you activate all of them that haven't been activated before, that haven't been activated before. And then you continue this process until you've covered all your vertices of your graph. So you continue this until no more vertices can be activated. In other words, all of them are activated already. So this one seems a little bit quicker, but the really interesting thing is this one's actually going to be slower computationally. And that is something you should just start thinking about, because remember, a lot of your stuff is not going to necessarily be done by hand, it is going to be done by computers and things like that. And in this regard, obviously, if your graph is really, really wide, in other words, you're going to have a situation where one of your nodes is like connected to all your other nodes. It's going to, well, not necessarily all your other nodes, but a large majority of them. When you do the situation of when you activate, all the adjacent vertices, there's going to be a bunch of nodes that you can activate. And this could cause a memory problem in that you have to store the memory, and then you also have to then look at all those activated vertices at that level and search through again. So this one actually ends up being slightly slower than the other one. Remember, the other one, you just select one and you move on. So there's just some things to consider, particularly if you're going to head into computer science, or particularly if you're going to, utilize this for certain things. And again, first year course, so we're not going to cover everything thoroughly. The main idea right now is that it creates a spanning tree of our graph. So it creates a subgraph, which is a spanning tree. But these are some of the things you need to just start thinking about. So let's go ahead and do an example. Okay, so what we're going to do is we're going to look at this graph and we're going to find the spanning tree using the breadth first search with our root node being E. So we activate E first, so let's write that down. Now what we're going to do is we're going to look at the adjacent vertices to E, so that is D, H, and F. And now the difference between the breadth first search and the depth first search is the depth first search you would only activate D. The breadth first search you're going to activate all of them, but you're going to activate them in alphabetical order. So you're going to activate D, then F, then H. D, then F, then H. Now what you're going to do is you're going to look at all of them on this level, so D, F, and H, and you are going to look at their adjacent vertices and activate the ones that are inactive. And again, you're going to do this in alphabetical order. So you're going to start with D first and look at all the adjacent vertices to D and activate the inactive ones. And then you're going to move on to F and so on. So the adjacent vertices to D are A and G. So again, you activate them in alphabetical order, so it was A and then G. Then you look at F, and you activate the vertices adjacent to F, which are inactive. So that is C and I. And you're going to write that down, C and I. Then you look at H. H has no adjacent vertices which are inactive, so we just move on. So now we look at A, G, C, and I, and look at all their adjacent vertices and activate those which are inactive. And again, following alphabetical order. So you'll look at A first, and there is none that are adjacent to it. Well, actually, no, I lie. A, you look at A, and A is has B adjacent to it, so you activate B. Now what you do is you look at all the vertices, and all the vertices are active, so you're done. So you have a tree. And how you would display this is, again, you're going to do it in order of activation. So it's E, D, F, H, A, G, C, I. So that's how you would give it. One of the other things you can do is you can actually draw it and do the search like that. So you would have had E, and you would be like, okay, well, all the vertices adjacent to E are D, F, and H, and you could draw it like that. And this one's going to show you a clearer picture of the breadth first search. Then you look at D, and you have A and G. Then you look at F, and you have C and I. Then you look at H, and you have nothing there, so you move on to B. So you can see that when you give it to us, you go by order of the transversal. So you start there, start that layer, and then you have this layer, and then you have this layer, and then you have this layer. And you go through it, so in alphabetical order. You go from there, and then you go from there, and then you go from there. Okay, one of the other things to note is that if you were looking at this graph, particularly if you drew it like this, you would be able to get a clear idea of how long it can take, or the length of the path from E to any other vertex C there. And it's usually the shortest path in the regards that starts from E to any other vertex C. Because you have your layers, so there's 1, there's 2, and there's 3, you know that to get from E to B, you can have a path of length 3. So that's just another thing to note. Okay, so here we have another example we're going to do, and this time we're going to activate E first. So E is active. E is your first layer, or level 0, whatever you want to call it. So we have E. Again, with breadth first search, we activate all the adjacent vertices. So in this case, it's B, it's D, it's F, and it's H. So again, you see how what happens here is now you have to deal with those 4 active vertices. So this is where we talk about the memory and the being fast or slow kind of situation when it comes to computers. Again, that will only happen next year, but it's just so that you can start seeing or grasping the idea and the differences between the two of them. Remember, with depth first search, you only activate one vertex and then you move on. So here we activate B, D, F, and H. Now we have B, D, F, and H active, we have to look at their adjacent vertices and activate them. And again, we do this in alphabetical order. So we look at B first, and we activate the adjacent vertices which are inactive, and then the ones that are the adjacent vertices to B, just by the way. So this is A and C. And I forgot to actually join your tree, so you can actually see the tree happening. Okay, so we have A and C. Then we have to look at D. D doesn't have anything that we can activate. Then we look at F. F has I. Then we look at H, and H has J. And we're done. So again, if we had to say this or answer this, we go by order of activation. So it's E, B, D, F, H, A, C, I, G. And if you want to draw the spanning tree, because you're not necessarily seeing what the spanning tree looks like over there, you could say, okay, I began at E, and you had 1, 2, 3, 4 branches. Here you have B, D, F, and H. They're all on the same layer. I know it doesn't look that layer-like. And then you look at B, and you have A and C. D has nothing. F has I. And H has J. That's an I, just by the way. So what you can see here is the shortest path to get from E to any other vertex in the graph is 2. So it's length 2. Because you have there and you have there. And again, this gives you a spanning tree. So this gives you a spanning tree on your graph. And if you're still not entirely sure what the spanning tree looks like, it is all your colorful areas. And it gives you a spanning tree. Remember, you can have multiple types of spanning trees on from your original graph. This gives you a version of one of the spanning trees possible. So again, it gives you a spanning tree that you can get off the graph, but it's also going to have applications to other things later on.